Electronic Basics, Video 5, LED Circuit. LED is the abbreviation for Light Emitting Diode. This is a diode, which is a polarized electronic component that let current flows through under certain conditions. There is a minimum and maximum voltage applied on its terminals. The current flowing through a diode cannot exceed its maximum value, and it must be connected with its positive and negative polarization. This is the symbol for a diode. So this line here corresponds to the negative side of the diode. Usually there is a line here on this small cylinder, indicates this is the terminal that must be connected to the negative terminal of the circuit. Now this is a LED, which is the same as a diode, but this one emits light. This is why it's called LED, Light Emitting Diode. As we look closer on this transparent cap, we can see those two terminals of the LED. There is a gap between this terminal with the other one. So what happens here is that when electrons is jumping from one end to the other one, is going to emit light. The electron gets excited and it starts to emit photons. So the photons, kind of the idea is getting trapped inside this capsule, and photons are small lights, pulsing lights, and that's why, depends on the color of the cap, is going to provide different colors of light. So as you see, the LED depends on the color of the capsule, is going to emit that particular color. This one will be transparent, of course, and this will be green, this is blue, this is yellow, and this is red. The whole principle is that when voltage is applied on its terminals, current is going to flow from one terminal to the other one, passing through this gap, and then emitting light. LEDs, just like its sibling, the diode, has a positive and negative terminal. And how you identify this? The longer leg is the positive, and the shorter leg is the negative. The LED symbol is the same as its sibling. The difference here is because it emits light, so we are going to have like two arrows out. That is the symbol for the LED. To operate properly, the LED needs a 2 volts applied on its terminal, and the current flowing through cannot exceed 20 milliamps. In this box, I'm going to set up a schematic circuit with these conditions. Number 1, we need to provide voltage. So here on this side, I'm going to provide voltage. And because I'm going to mount my basic circuit with LED on my breadboard, I'm going to use the power supply module 5 volt settings. So that is 5 volts. So this will be my positive. So the longer line is the positive and the shorter line is the negative. So the symbol for this LED is like this. And this is the negative and this is the positive. So this negative must be connected to the negative side of the battery and the positive with the positive. So this you can flip, you can move around. So here will be my triangle like this. This is my negative and is connected to my 5 volts battery. So this is my negative and this is my positive. And so the requirements for polarization is follow right here. Negative connect to negative, positive is connected to positive. However, there is a problem. The minimum voltage here, or the operational voltage for this LED is 2 volts. And here we have 5. So if you apply 5 volts here, this is not going to work well. Now we are going to use a resistor to share this energy of 5 volts. So I know this is 2 volts. So I need a resistor that is going to take 3 volts, because 3 plus 2 is 5, and then I can save my LED and can operate correctly. Great, everything looks good, but what is the value of this resistor? By Ohm's law, we know that resistance is equal to voltage divided by current. We have voltage, which is 3 volts, but what is the current? Here, the maximum current that can flow through this LED is 20 milliamps. So that tells you this is the current that is going to flow through the circuit, which is 20 milliamps. Because this resistor is in series with this LED, so the current flowing through this resistor is also 20 milliamps. So to find the value of this resistor, we just need to divide 3 by 20 milliamps. Now remember that milli is a multiplier, so is 10 to the minus 3. So we just need to plug in the calculator and find the value of this resistor. 3 divided by 20 EE negative 3 is 150 ohms. So 150 ohms is the minimum resistor value. So let's review the requirements. Number 1, is the LED connected to the right polarization of the circuit? Yes. Number 2, is a guarantee that just 20 milliamps is going to pass through this LED? Yes. This resistor is going to do the job, because 150 ohms is going to limit this current to this value. So we are good to go. This should be the resistor. To make sure that is 150, I'm going to check using my multimeter. So connect here. It's not polarized, so it doesn't matter the order. Positive, negative, it doesn't matter. And now I'm going to 200. Perfect. So this resistor is 148.9 or 149, which is great because the tolerance is smaller. So this number fluctuates a little bit below 150 or a little bit above 150. So this is perfect. Okay, so I'm going to use this breadboard at 5 volts because that's what I use for my calculation. The layout of the circuit is entirely up to you. I'm going to show you how I do. To keep in track with my polarization, I like to use my right for the positive. So the longer leg here of this LED, the longer leg is the positive. So I'm going to make my positive. You make your positive. I'm going to make my positive to my right. So I'm going to connect this LED, open the legs a little bit, and connect on this row and connect to this row. Okay, you can feel when it's inserted correctly. All right, so it's there. So now my resistor is not polarized, so it doesn't matter which way it's gonna go. If it's gonna go to this side or to this side, I'm going to move this guy to the negative. So I'm going to connect. Make sure that you are connecting with the correct row. Remember, those rows, they are in series, right? So right here is in series. You see, the resistor is in series with the LED. Oh, in this case, I'm gonna do something different. I'm going to move it to the other side just because it's following the circuit. So the positive one is connected to the resistor. So there you go. The positive one right here is connected to the resistor. And this guy, because it's so long, I'm going to connect to the positive right here. Positive. So let me show you closer. So I have my LED. This is the positive here, and it's connected to the positive. Okay, to this bar, because I have 5 volts here too. And now I'm going to get a wire. Let me find a wire here, a small one. There you go. Any wire. And then I'm going to connect the negative of my LED. All this is series. See the negative to my voltage negative right here. All right. So now let's see if it's gonna work. I'm going to press power on, and voila, the light is on. Beautiful. Okay, this is a sample circuit. What if I want to have several colors connect to the same circuit? How I will do this? So next, let's do a schematic circuit. My voltage is the same. I want to use my 5 volts right here, 5 volts. And right here, I'm going to draw the circuit that I already have installed on my breadboard. So here is my negative, my positive, and the positive is connected to the resistor, which is connected to the positive side of the battery. And the negative is connected to the negative side of the battery. And this is 150 ohms. I'm going to do the same thing here, and I'm gonna use another color and another here and another here. So I'm going to mount on my breadboard 4 colors, 4 LEDs, and because it's in parallel, my resistor here is the same, because the voltage across this section is also 5 volts. So now I have positive and negative, and I'm going to have right here 150 ohms, sorry, ohms, and my LED, negative, positive, and another one, 150 ohms, and negative and positive. So let's see what I get. I'm going to move this resistor. Instead that far away, I'm going to move right here. Now that I move, I just want to make sure it's still working, it's fine. So now I'm going to mount the other colors What about a green here, and then a blue here, and a red here? So let's see what happened. Remember, the positive is the longer leg, and my positive is on this side, on my right. In this step, the red, green, and blue LEDs are connected in the breadboard following the same polarity as the yellow LED, which means that the longer legs of each LED go to the negative power bar on the right. Here, a closer look. Following my schematic circuit, each resistor of individual branch is connected to the positive leg of the LED and goes to the positive side of the battery. So now I'm going to connect. Need to bend a little bit like this. So connect to here to this. Is in series. Now remember, these set of rows are not electrically connected to the other one, but when you use the LED, you use like a jumper. So now you are going to connect those two rows through the LED. So now I connect here and again to the positive side. And likewise, the next LED here to the positive. And the last one here and positive. So this is how it should look like. So it's kind of a repetition of the first circuit because they are in parallel. As you see, in the schematic circuit, all LEDs in series with the resistors. Let me rephrase. All LED, each LED in series with the resistor, but they are in parallel with each other. So let's look here. The LED is in series with the resistor, but they are in parallel with each other, which means that I have 5 volts across each individual circuit. Now I'm going to connect the negative side of each LED to the negative side of the voltage source. So any place here should be fine. So here, to the negative. The next one, to the negative. And finally, this one, the negative. Now, this is how the circuit looks. So as you see, they are all in series, this one and this one, and they are all in parallel with each other. Now let's test if it's working. Oh, look at this. The blue one is not working. So let's take a look why. So as you see here, the resistor is not in series with this LED. So I'm going to move this leg to this and make the correction. So this leg needs to go here. Okay, I move. And now let's test again. Perfect. So you see, a simple mistake like skip a pinhole, connect on the wrong location can lead this type of problem. Beautiful. And now you have built a LED circuit.